a measure of the pollution that you see in the air. The large dips that you see here are clouds that block the sun photometer and the sun. Okay, clouds that block the air between the sun photometer and the sun. Okay, that's the large dip. But the small dips, they are the pollution in the atmosphere that are between the sun photometer and the sun. This is, upstairs you see it later, a cheaper instrument. It costs only $500,000. However, this one has no space information, does not know where the pollution was. Okay, it tells you that between the sun photometer and the sun, there was this much pollution. Yes. Unlike the LiDAR, which tells you where it is. Actually where, at what time. With modification, it will tell you what it is actually. Is it ozone? Is it sulfur dioxide? Etc. etc. This one cannot. It just tells you it was this dirty. More basic measurement, for all of us, maybe that would be enough. If you know it's dirty, don't breathe. Okay? Put a face mask. Okay? Maybe that would be enough for even the poor people. But maybe for the scientists or whatever, we want to know what it is when it was there. We want to know more information. This one is real time. So it's getting data now. Then I just use a program. The student who was here earlier, he created this. He created this from scratch, nothing. So just use a software to build this program. So he did this all by himself. So we just taught him how to do it, step by step. For his bachelor's and for his master thesis, he did this. It's a big program actually. So there are so many things in it. Because you have to check if it's working properly, so there has to be error checking, the equations that we use to process, to make the motor so because it has to track the sun. The sun does not stay always in one direction. It will go from sunrise to sunset, travel across the sky. And then it's not following that same path always. Today moves this way, tomorrow it moves the same way. No. It will move, maybe in December, it will move this way. We don't get too much sunlight in December. Diba? Days are shorter. So the sun does not go higher up in the sky. In summer, the sun goes higher up in the sky. That's why we have a longer period of daylight. Okay? So, that student did this. So it's now getting a measurement. Again, we just use programs. We put them into here, make the program from the equations, and then we can process it. We can get how dirty it was at this exact point. So real time, cheaper. Okay, and then what we're going to do next is, this is $500,000. We bought from Australia. Actually, it's not the top of the line instrument for this kind of measurement. So one of the instruments that we're trying to build right now is an LED-based sun photometer. So same concept, but now we want to build it locally using LEDs. This thing here is an LED. LEDs are used almost everywhere. Like for example, power on indicators. Okay, even in your computer, LEDs, diba? So it for us gives light. Tells us if that thing is on or not. Actually, you can use it as a detector. You just chop its head off. Take off the top part, sandpaper it off, the top part, and then you connect an integrated circuit. Don't ask me what. Then, of course, a resistor. You put in a volt power supply, and then connect everything. 2 wires out, shine light on it. It gives you a voltage. Put some dirt in that space in between, gives you a change in the voltage. Of course, if there were no dirt, no pollution, if I send 100 watts of light, sunshine here, it will give me 100 watts. If there was pollution, it will give me less. Okay, gets? It will give me less. Then, from the amount that I measure, I can know how dirty it is. That's the basic concept of sun photometry. Okay. Okay. So what we're doing is we're building something like this, an LED-based sun photometer. So one of the professors is experimenting over there on the response of this. It's green. So therefore, it will respond to green light. Okay? Sunlight has a green component. You don't see it because sunlight has a green component, but the peak of the sunshine, peak wavelength is in the yellow part. That's why we see it as yellow, because the peak is in the yellow, but it also has green. It has infrared, it has UV in it. That's why you use your suntan, etc. Diba, yung mga lotion. Then, because this will respond in the green, it will take in green light. But if I have red, I can get it to respond to red light. Okay? Then, it can perform like a sun photometer, the one that you will see upstairs. Cheaper, definitely, not $500,000. Okay. Just a few thousand, maybe 5, max 10, including the power supplies. And then this uses voltmeters. You know what a voltmeter is?
No.
Voltmeter. Voltmeter. If you want to measure 9-volt battery, you set to DC, and then put this there. So what we do is, of course, here, inside here, you have those LEDs. Because the sunlight enters here, and then inside we have the LEDs. To know if we are pointing towards the sun properly, we have the diopter here. Okay, I'll show you upstairs how it works. So the diopter, when we point towards the sun, we see a shadow here. If it's pointing properly, then you see the shadow here. Okay, there's a certain way. Okay, if it's not pointing properly, if the sun is here, of course you don't see anything. If the sun is properly aligned, then you see the diopter. Okay, so we just connect here. Of course, a box that will what? So this thing goes here. Outputs of the LEDs, as I told you earlier, to give us voltage. Outputs go here. We just put our voltmeter. Put the voltmeter here. We just put 9 volts batteries here, plus 9, minus 9, and then we're done. We're ready to make a measurement. Of course, that's just the measurement part. Because this is, if you want it cheap, this is the cheap solution. Measurement. So, labor intensive. Okay? That's not labor intensive. It's getting data even if nobody's here. If I'm at home, as long as it's properly set, it will get data. I can watch a movie, do anything I like.